anyway, she's going to once to get my thoughts together, arrange calls with each of the people in that hierarchy.
Yeah, okay. So I think we can certainly, the CRM provides all the essence of those items, and we can
Oh yeah,
certainly,
yeah, yeah. I
use
think
that as a
it's
demonstration.
it's a useful acid test
Mm.
to have emergency services dispatch in the background, but looking
Yeah,
at it, there's no way we could sell into that area anyway because it's all circles and big integrators and so on.
I wouldn't
Uh,
be so sure about that, man. Like there's a lot of emergency services all around the world of varying degrees of officiality and, um,
that's
y-
true.
and they all got the same problem.
That's true. I had a very, very quick skim over this MIS emergency systems, and they have a lot of devs.
Yeah, right. That's it. Those types of
Yeah.
systems are ones that we can take a swipe at.
Yeah.
Okay, so the CRM will, because you can also use like some of the more advanced features and integrations I want to do for the CRM are things like when a
Mm-hmm.
customer rings up, I want to be able to be tapped into the phone system, so I want the VoIP system to come through us, which
Mm-hmm.
means that I can determine what phone number they came from, so I can pull up the customer record and history, um, without anyone lifting a finger, so that when the dispatch operator is reading it, they're already primed without having to ask annoying questions like, "What's your customer number?" and
Yep.
other such
Well,
things like that.
there's a whole bunch of integration in the background there, but essentially that's an event, and that
Yep.
event can kick off.
Yeah.
You look for who's calling.
Yeah. Yeah.
You've
That's
got
right.
a
That's right.
customer.
That's right.
Yeah.
And then, further to that, in terms of ambulancing, you could do voice recognition on the voice to see if it's a likely to be a crank caller or one of those,
Or
problematic
frequent flyers. Frequent
frequent
flyers.
flyers. Yeah. So you're like, hey, warning. This is
Yeah.
a blah 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 blah.
Yeah. You've
Something like
called
that.
an ambulance 9 times today. Where you're going to be low priority.
Yeah. 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 Okay. That's fucking great. So, um, yeah. I got two things I wanna go over.
Mm-hmm.
Um, the so after I got a bit of a poke from my friends about the different security aspects of this, that, and the other thing, and realized that yeah, we do need encryption at rest. And
Mm-hmm.
then the question came, well, where do you stick the key? And the key is probably in the so Deno deploy has a secrets place where you can put secrets for your application, like keys to the
Mm-hmm.
database and other
So
such
you
important
you have
things.
your own personal key to allow you to access to Deno, and Deno then gives you access to other keys. Is that right? That
Uh,
happens.
yeah, I sign into Dino and then I can insert a key, which is supposedly encrypted, and that only when my program is running can it have access to that key. So I can never read it again once I've entered it. There's no way that I know how to read it. But for example, that would be the encryption key for the database for me to
Yeah, no,
encrypt it.
that's fine. That keeps. Sorry, I interrupted you there, but that's fine. That keeps the chain because you've had to log into Deno. That's the first part in the chain, and
Yeah,
then they've got their own key.
right. But there was so I ended up having a discussion with one of the guys that used to work at Deno about it, because I was like,
Mhm.
well, that's it's not that that's not good enough. It's just that I would like to. There's a better way, because I said, well, what if someone reads all of the Deno secrets and they read my copy of the database? Now my encryption's worthless because they can access them both. So I was like, well, okay, can I?
Yeah,
Uh,
we
uh,
were Yeah, that's the third block from yesterday. We were abstracting away, saying that's Deno's.
Dino's
We'll just
problem, right? Yeah,
we'll inherit
yeah, yeah.
what
And
Deno
then
does.
so I was like, I suggested to the guy, well, what if I set up an external secrets provider like AWS Secrets or take your pick of a external secrets provider.
Mm-hmm.
And then I hit on an idea that I suggested to them quite strongly. And so this is JSR.io, which is a replacement for NPM that Deno have made. One of the good things is that it's, well, amongst other things, it's TypeScript native. It's basically a modern version. NPM is coming up to 10, 15 years old. It's got a lot of legacy shit in it. This is much more modern. So down the bottom, they've got this thing, right? Built and signed on GitHub Actions, and you can view the transparency log, which shows you the fact that it ran in one of those isolated, secure environments in GitHub Actions. Here's the attestation from GitHub saying, yep, I'm pulled it from this URL. I used this hash commit. I then built these things, and here's the hashes of the outputs signed GitHub, right? So that's amazing actually in itself, but that's not what I'm trying to suggest. One of the attacks that the guy I was talking to suggested was a pretty fatal attack. He was like, well, it doesn't matter what you do with your key management, but if someone can create a new deployment in Deno that does something as simple as reads the key and then console logs it to something that they can read, everything you've done is wasted.
Yeah, but their vault that's what the security of the vault is, the thing that would have to penetrate.
Well, the security of the vault, yeah, but if they can get hold of my keys that I use to make a deployment, then they can also dump the live running key as well. So yeah. And so what I suggested to them was, look, guys, it'd be fucking great, because what's really good about JSR is that when you publish a package, you don't get to just push up any old thing. You have to connect the GitHub source, and then when you push a GitHub source, when you make a commit, they do the building using GitHub's compliant
green
tick isolated machines, right? And so the point here is that there's this commit that's hashed and preferably signed by you, that then you don't get any more say over how that gets built, because you needed to have supplied all that in the source code that was used to generate the packages that everyone's going to consume, right? Which is that's supply chain provenance, the current state of the art on it. It's can be better, but that's where we're at, and that's pretty damn safe, because if I want to introduce a fault, I have to do it in the source code where it's visible to everyone, and then I no longer can insert stuff during the build process, because it used to be like an NPM. I can say that my package came from this commit, but I do a build step, and I can put anything I like in there, and there's no way to tell, because strangely enough, deterministic compilation of code is not a thing and hasn't ever been a thing. When you make the code, you can't guarantee that you get the same result twice, which is annoying, but
which is where Stuxnet came from.
So yeah. So anyway, that's sort of what this does. And I said to them, look, wouldn't it be great if in Deno deploy I could do that same thing, where I give you the GitHub hook, which you already have, and then you build it in a tested, secure building environment, and then you publish it to the web, and you guarantee everyone that comes to that page that from the source commit to the SSL secured page that's being delivered, nothing was tampered because it was all done in this certified environment, and there's no way for me to get in there and change anything, which would remove that attack scenario where someone comes into my Deno deployment, makes a new deployment, dumps my keys to the log, and then does a runner. Because if Deno deploy is made to be ballistic, it can be put into this ballistic mode where I can't actually alter it other than altering the source code. That's a really, really strong guarantee to give an end customer when I'm the supplier of some software, because I'm like,
it's well, 2-3 steps further on than anything I've seen in banks.
right, because the deployment process has got these massive leaky holes in it, really, because you can fucking insert anything you like in there, and who would know, really?
Yeah.
But if you use the same thing as the packages, but just for the deployment, you can have end-to-end provenance of your web app. So you can go from the fucking SSL cert all the way back to the source code. And you don't have to trust an individual developer to have not been compromised and also not be a dick, because you're like, the chain of trust goes, your browser, Deno, GitHub's runners, Git.
That is pretty sweet.
It's really strong, and I am so excited by that concept that I think that they will. I don't know why they haven't done it already, but I think that they'll see that and go like, man, that's a cool thing to have. And so, for example, like HIPAA and other types of compliance regulations, we could sidestep all that because we're like, well, they have the Deno deploy has the compliance, they have the operations that are subjected to all these compliance rules, and we can show you that we can't actually alter it other than this source code. Then you get the source code audited, and you're like, here's the operations. Ta-da! Low cost, compliant data processing.
And of course, the provenance of the source code alteration is also known.
Yeah. So that
I'm really impressed by that.
It's subtle, but it's fucking it's doable by these guys. They've got all the components they need to give us a ballistic web hosting platform that has end-to-end provenance. And yeah, I think that's a good thing for them to make.
That's very, very impressive.
It's fun, right?
It's probably way more than we need.
It is not enough for us. We need more, but so what we need, because the issue is still, this is great, but this still requires us to trust it.
Yeah.
And the issue is that the output of doing this run is not repeatable. And so that's really the fundamental issue with computing, is that the lack of repeatability. And so that's why I need this air-gapped environment, because I can never ever get the same output from that code ever again. That's the problem. We need to eliminate that, so you don't need so you don't have this green tick anymore. You can just fucking do it yourself and get the same answer, the same hash.
Right.
That's the next step up. Yeah. Anyway, so where I got to with implementing this user model today is that actually I needed to implement keys, like signing keys. And so the model I've got now is that I took a bunch of shortcuts, namely like, hard coding the super user ID at 0 and other things like that, just so I could fucking get something running. But to implement this model properly seemed like only a tiny amount of effort more. It seemed more effort to deal with the shortcuts and keep them in mind than it did to actually do the genuine thing. So the way the changes that I want to announce to you that may be surprising is that every repo I've given it now has a chain ID, which is basically the hash of its Genesis block or its Genesis commit. This commit will be unique in the universe, and that's what identifies the repo. Even though we are running the red line as all our stuff on Deno deploy, we should be treating each repo as a globally unique, cryptographically verifiable unit of trust. And what's changed is that when you pull from GitHub, the name of the repo is going to be meaningless because it's the chain ID that everything refers to. So right now, for example, the repository Dreamcatcher Tech/Hal was important. Now that's going to be not important because it's all just these secure IDs for the repos, and the fact that it holds a repo that's referenced on GitHub is sort of becomes bookkeeping information rather than addressing information.
All right.
So
if you have a universal hash, then you could have various Git instances, and it's up to you to decide whether you want to accept the security of the particular instance.
Yeah. And all that is to say that we're working towards this verifiable repeatability piece, because just because we made this home repo, this home NAP, just because it runs on our instance of Deno deploy, ideally we want it to be running on multiple deployments and subject to consensus, which means that it needs that cryptographic hash to guarantee its uniqueness in the world. And so that's what I've implemented, am implementing right now. I do not think I've got very long to go at all. I feel like in the next day or two, I'm going to be able to kick up a working model of this whole system. And at that point, we are, I don't know what the word is for it, but our primitives are complete. Like that's the thing that from here on in, it's all apps. Yes, there's tweaking. Yes, there's performance, but feature-wise, it's like that ain't all the features, but it's enough of the features, and it's genuinely designed to be a decentralized system, albeit that it only runs in Deno deploy right now. So, yeah, that's all, man. That's where we're at. That's what I was trying to.
I'm gonna have to think about this because you're introduced a couple things that are really cool, but I've not experienced before in terms, of.
If you got questions, man, hit me, because I'm nervous that I've done. There's so many components that I've sort of, and so many iterations I've gone through in the last week, that I find it very beneficial to talk about and answer questions about it to help it stabilize it for me and make me feel more comfortable, so that when I implement it, it's much more intuitive, because I feel like I understand the whole rather than just.
Right.
Yeah.
Well, to make that a valuable session, what I'll do is I'll review yesterday's and this session, and I'll try my best to kick holes in it.
Okay.
From random places.
Okay, cool. And
But
importantly,
again,
what I would find useful is for you to check that features you're expecting or historical features that were spoke about are still present, and then I can explain, how they work.
right. So run through traceability through it and
Yeah.
see if any of this stops.
Yeah, because
What
if
we're
it's
trying to do.
awkward for me to explain, it probably means it's not designed right.
Yeah. Okay. All
Uh,
right. Right. I'll spend a bit of time this afternoon doing that. We can do that tomorrow.
mm. So
But
again,
on the
sorry.
sorry. No, I was just saying on the
To,
first blush of it, it seems super solid.
It's super solid. It's complicated for doing simple things, but the fact that it can extend to very complex things is what makes it seem
Yeah.
good, I think. So again, I want to reiterate the key concepts that are new that still need, the new concept is this concept of an actor. So there's machines, which represent a piece of secure computing equipment that can hold a private key, public key pair. There's sessions, which are the way that external excitation enters the system, of which a machine can have arbitrarily many sessions running, but they're all managed by the machine's trusted environment. We have the concept of an actor, which is meant to model a human, but it can model any entity that has machines working for it. So you could make it an autonomous thing and the machines are connecting in, but typically it's a human. And then we have apps that mirror this actor notion for the purposes of isolating the incoming requests and the permissions model of the data inside of the app by modeling an actor against which all authorization is matched against, and that actor can have arbitrarily many sessions, which indicates independent threads of activity that's sort of at the app's discretion how they want to define a session, and that sessions in an app are only loosely related to sessions in a machine. You don't have to have a one-to-one mapping. It just so happens that it's convenient.
What's the red lines? The red arrows?
The red arrows were a really interesting concept. I was worried that there would be a lot of delays in the action. So the action would start here and it would go there, machine, actor, HAL, actor, session, or, session, machine, actor, into the session, then into the actor, and then into HAL. But then what I realized was that because each session is a branch, the branch has a full copy of all the files at the root. And so it's sort of like, if the process cannot come to the mountain must come to the process. And so there actually is no hopping because the session
taking a whole chunk.
The session has the whole the entire file system, however big it is sitting right there. And so it's like, that was just completely not a problem. The next problem is that periodically the base needs to sync with the session, and when the session has something it wants to change, it needs to merge with the base. So there's a little bit of a dance to be done there as to when should I merge, should it be automatic, how do I deal with conflicts, those types of things. But that's what the red arrows indicate. They indicate that actually a branch is a full-blown copy or full-blown, it is the main repo, even though it's a branch. And
right.
yeah.
Okay.
Yep, and then so other features I still got to implement billing, which metrics and billing appear to be the same thing actually under the hood. I'll just chuck that in.
Well, billing should be a piece of piss after this security model.
Yeah, let's hope so. Because I still got to put payments in this model somewhere, but I'm feeling pretty good about the model because it seems easy to add arbitrarily many pieces. And whilst we're starting with GitHub, I'm excited to very, very soon, or very, very soon, add Ethereum login for us. And then that can sort of tie in with the work on the DAO that I'm doing for Satoshi Island. So
yeah,
their people will be able to come in, use the Ethereum wallet to authenticate, and then, here's some AI. And that's the CRM is the piece that I'd want to present first as the DAO, because, the business rules, the duty manager concept, dispatch, a customer. Customers are people who own NFTs. They own these NFTs, they got questions, they want to do some stuff, they got all these things, and the CRM's there acting as a DAO.
Yeah.
But it's all the same logic.
Yeah. It's interesting. This is a half-formed idea, but I was thinking about it essentially. Where essentially, dispatch is really the temporal organization around the change of state on NFTs. It's if you at the very highest level, that's what dispatch and pickup really is. It's like we're moving, something that, for example, the an NFT can also be an event.
Right.
So the emptying of your bin, it's like you can't have half an emptying of a bin.
Right.
But you can. But you know what I mean when it's empty.
Yeah. Right.
And that model seems to be really quite pervasive. There's quite a lot of areas from scheduling, I don't know, aircraft to Ubers.
Right.
To
so I would
calls.
think of an NFT would be minted each time there was a bin collection, because that's and then
that's the important state change.
Right? Yeah. And then when you get a bin delivered, you are being issued a temporary NFT. But when the bin is collected, you've been minted a permanent NFT, because that event irrevocably happened. You paid for it. Your NFT is your receipt, basically.
Well, somewhat like a promise, isn't it? An empty bin is somewhat like a promise, because otherwise it's pointless. But it's
like a membership. It's a membership NFT is how I think about it. You buy the membership NFT.
Something there is quite interesting.
Yeah.
Yeah. So anyway, that was a very poorly formed thought at the end there, but I think there is some kind of pattern.
Yeah. No, there is.
The emergency services thing, I think, is the extreme case. The CRM is definitely the thing I'm going to do first, because even just looking at the emergency services, like, whoa. And then I've got my other kind of back of my head thing, which is how on earth did they organize D-Day just using paper?
I know, man. That's fucking insane.
And it was successful. But let's, so today I'm going to iterate, as I was saying, on the CRM. Tomorrow we can go through that. Might not get a chance to go to this because this is really, really fucking interesting, but might end up with a rabbit hole that I don't end up with a CRM getting on with or prioritizing. Right?
I mean, I'm sorry. I'm sorry for the delay. I'm bad at picking when, but it feels almighty close to having a basic working version, and then we can start building the CRM, because I'm actually gonna I think skip HAL as the app and replace that with CRM, and then we can start. I mean, if we need HAL back, we can put it back. But I think that the CRM app is actually the thing. HAL will fall out of that if we build the CRM right.
Yeah. Well, how's just a placeholder for the one and personalized app that Dave interacts with.
Right. Yeah.
So, yeah. When you're talking about a CRM, actually, the CRM interacts with you differently if you're a customer agent, if you're a duty manager.
That's right. Yeah. Yeah,
So,
it's prompted differently depending on who you came in as. Yeah. So we'll probably I'll try and lay down a scaffolding version of HAL that gets deployed online, and then we can figure out how best to incorporate your work there, ideally so that you can do your work in the platform.
Yeah. Cool.
Yeah.
Damn, this is so close.
I know, dude. It's so fucking close.
Well, you keep, I know you're saying like 1 or 2 days, and then I'm saying 1 or 2 days. And it just feels like 1 or 2 days.
I know. I'm like, fuck, I'm not lying.
It might be a week. It might be a week. It's like, but it just feels like that.
It's so close.
It's because there's the path is clear. The execution might throw up stuff. But the path is clear.
Yeah, but man, it'll be fucking great to have a deployed version being used by customers. Like that's just so much win.
I'd just love to like sit, virtually behind their shoulder and see them.
Yeah, well, what'll probably happen is I'll probably go down there for a couple of days, and then I'll VO you in, and then
if we can log all their sessions.
Yeah, well, we will be by default.
Ship those back, and then I can look at those, and I can get my HAL, who is starting to know me, to look at those. That would be really fucking useful.
That's right. Yeah. So then there's that commissioner app, or that secondary sort of a studio app that lets us analyze user sessions using AI instead of having to read it through manually, right?
Yeah. Oh god, yeah. The sessions generated are going to be large, but I've got quite an affection for my HAL prompt now.
It's looking good.
He's a good dude. You know? He doesn't fuck me around anymore.
It's pretty good.
But anyway, right.
All right.
I got into it.
Okay.
All right, man.
I'll see you later, buddy.
Yep. See you, man.